In this question, we've been given 4 particles each of mass m orbiting in a circular path of radius r due to the effect of each other's gravitational forces. This particle is revolving in the circle due to the gravitational forces acting on it by these 3 masses. This one is rotating due to the gravitational forces acting on it by these 3 masses, and so on. Now, why does it need the other gravitational forces for its circular motion? The simple reason is that whenever there is a circular motion, there is an acceleration equal to v square by r to direct it towards its center. So for any circular motion, an object needs a centripetal force which acts towards the center of the circle. So for this mass m at the top, it needs a centripetal force which is provided by these 3 masses. We can directly see that the resultant of the forces due to these 3 masses comes in the vertically downward direction. Because the resultant of these 2 forces comes in the downward direction and the force due to this force comes in the downward direction, they're adding which we get a resultant force in the downward direction which we needed. Now let us find out the resultant force in the vertical direction. Let us name the masses A, B, C and D. Force on A is equal to force on B plus force due to C. Force on A is equal to force on A due to B plus force on A due to C plus force on A due to D. We can directly find out the vertical component of all these forces because the force acting on A due to B and D, the resultant of these 2 forces is in the vertical direction. So if we take the component of this force in the vertical direction and the component of this force in the vertical direction and add them, we'll get the final result. So what we need to do now is add only the vertical component of the forces. Now in these 4 masses, we have the radius of the circle to be r, therefore the diameter is 2r. This is r, this is r, this is root 2r. Therefore the force on this angle is 45 degrees. Therefore the force on this mass due to this mass is equal to gm square upon root 2r whole square, that is 2r square. We have to take the component of this force in the vertical direction, that is cos 45 degree, that is 1 by root 2. This same y component force acts on this particle due to this mass also, so we multiply this by 2. Now we are left remaining calculating the force due to this mass, which is gm square upon 2r whole square, because the distance between these 2 masses is equal to the diameter of the circle, that is equal to 2r. So we add up these forces to get the resultant force. This resultant force can be written as the centripetal force, that is equal to responsible for mass into centripetal acceleration equal to v square by r. This is v. So from this formula, we directly get the velocity of the mass m. So on solving this, we get the final answer for the velocity directly as gm upon r into 1 plus 2 root 2 upon 4 whole to the power 1 by 2. So this is the final answer and the velocity in which this mass m should be moving when this is held by the forces due to these 3 masses.